Okay, so let's go for it. I just label this as a P.1 or P.1 homework questions from there. So the ones that did their homework from Tuesday's class. Any homework questions that you guys encountered that you guys got stuck on?
I got stuck on number 49.
49?
Yeah.
Okay, anybody else? Going once, going twice. 55 I heard, and 15 I heard, yep. Any others?
67.
51 and 67?
Yes.
67, okay. Okay, any others besides those? Going once, going twice? Okay, so the ones that did not do their homework, you're at the mercy of these people here. Okay, start off in order. Let's go back to 15. We'll handle our way as we go up. So convert each decimal to a quotient in two integers. This is 3.75. So how do you convert this here? We did something similar on the notes here. We're going to actually just let x equal 3.75. Okay, this is the one that actually stops. So remember, there's two different kinds, right? The ones that keep on repeating themselves as a decimal, those you got to do a little differently. The ones that stop because it's just 0.75. We're going to multiply both sides of an equation just because we're allowed to, right? We can multiply both sides of the equation by 5 or by 20 or by 38. In this case, we're going to multiply it so we get rid of the decimal. To get rid of decimals, we're technically multiplying by powers of 10. So if you want to move it twice, we're technically going to multiply both sides by 100. So that's going to be 100x is equal to now 375. Good there? Hey, got rid of the decimal. That's exactly what we wanted to do. And so now what we're allowed to do is just to divide by 100. And this will give us a quotient, technically a fraction. This guy, in case in a proper fraction. Okay, this guy ends at 5. I assume that 5 can go into this. So 5 goes in 37 7 times, makes 35. 25 drops down, so 5 times 5 is 25. So 75 over, and looks like 5 goes into 120 times. Hey, it could still go into this by another 5, is that right? 5 goes into 7 once. 15 I hear, yep, that's cool. And so that's going to be a 15 over 4. And that will be the final answer. Okay, good there with number 15. Going once, going twice. Question?
Can we do number 19 since you continue?
19, sure. I'll drop that into here. Okay, the other type is number 19. It's 2.13, and this little bar just means it keeps on repeating and repeating and repeating and repeating. So let's actually write it out. We're going to say let x equals 2.13131313, and put a dot 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 behind it. Okay, in this case, what we want to do is we want to multiply both sides. We want to multiply to the next repeating cycle. Since two digits are repeating themselves, we're going to still multiply by 100. If it was 3 digits repeating themselves, we would multiply by 1,000. Good. And if it was just 1, we would multiply by 10. So in this case, let's multiply both sides by 100. So this will be 100x is equal to, looks like 213.131313 forever repeating. And we're going to do this little trick here. The trick is we're going to subtract the x away from here. So remember, x is equal to 2.131313 repeating. And so when we do that, 100x subtract 1x makes 99x. And this is going to be 211, is that right?
Yeah.
And because the repeating, it's going to subtract itself off completely forever. That's kind of cool. No decimal anymore. So then divide by 99 is perfect. Cool. I'm going to just check just to make sure. Okay. So 211 over 99. I guess 9 can go to 99, 3 can go to 99, is that right? The way to check, anybody know how to check whether 3 goes into 211? Cool, hey, you add them up. 2 plus 1 is 4, plus 1, oh, sorry, that's 3, plus 1 more is 4. Get to the answer. And 3 doesn't go into 4, therefore 3 won't go into 211. So, final answer, 211 over 99 is our final answer. That's the repeating problem. Okay. All right, jumping to 49 looks like. All right, we have to play around with a little set notation here, or just sets in general. Let me quickly write it out. Okay, so what we need is 49 says B intersects C, and after you do that, then you're going to take the union of A. Whew, okay. So in parentheses, just like in parentheses in mathematics, that has to be done first. Then we combine that together. So let's convert all this into sets. Maybe a little bit. So B and C, remember this is intersection. So what do B and C have in common? -3, is that right? -3, 0, and 2. We good? So -3, 0, and 2. Union with A, and we can set this up as just in terms of sets only. So intersection means what they have in common. Union means you just put it all together. There's one big old nice pie. So in this case, it's a union symbol. We're just going to put both of these guys together. Only thing we're not going to do, we're not going to repeat numbers. That's all. We'll just write them once.
Do we have to draw a graph with any of the union or
No. No, just give me what's left over in the set. So in this case, see, we'll start off -4. Let's start going from lowest to highest. Even though with sets, you actually don't need to. There's no order in sets. You could write them in any order, but it kind of helps to write them from lowest to highest. Kind of see if you skipped any here. So -4 gets to go down, -3 gets to go down, -2 gets to go down. There's no -1 in any one of these, so whatever, can't do that. Zeros in both of them, that's good. No 1, but there's a 2, and there's a 4. Okay, good there. I'm going to check whether the back of the book is correct, because I got to check that sometimes, just to make sure they did it correctly. And it's correct.
So whenever you got the union of like below of B, the intersection of B and C,
Uh-huh.
how did you get the numbers below?
I just start writing down the numbers. If they're at least this set or this set, it doesn't matter. If I have a number, if I have that number in any one of those sets, I get to write it down.
Because like those numbers can come from B and C.
We already did this part here. That part is already done. So once you do this part, just like parentheses in math, once you do that, you're finished with that part.
So you're just writing the step.
Then you're just writing the union between these two sets.
Oh.
Cool. So 2 steps in a sense. Cool.
Because I was confused of how you got to 4s because I don't see 4s on the intersection. You know, like where it says
Yeah, no, the -4 dropped out here because it was the intersection, but the -4 came back in because A had it still.
Oh, okay.
Because it's step 2 of the process. All right, 51 and then 55. 51, still this good stuff here? Okay, a little bit different now. Now it's going to be the union of A and B as step 1. So all the stuff that's in A, all the stuff that's in B written down as one big group. So I'm going to do it from the textbook here. A is -4, -2, 0, 2, 4. B is -3, 0, 1, 2, 3, 4. So since it's union, we just start writing stuff down. So -4, -3, -2, because A has -2. Either of them, they don't have -1, so I can't write that one down. But they both have 0, so I could write down 0. B has a 1. Both of them have 2's. B has a 3. And both of them have 4. So there's the union of A and B. Now we're going to take it with the intersection of C. And C is -4, -3, -2, -1, 0, 2. Now intersection means what do they have in common? What are the numbers that's both in the first set as well as the second set? Anybody want to help me out? Awesome. -4, -3, -2, 0, and 2. Ding, 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 ding. It's almost actually set C, is that right? Isn't it almost like set C minus the -1, right? Take away the -1. So it's all that work was just to get rid of that -1. Okay, next one. 55, is that right? Just want to make sure, is that part of our homework for 55? I guess so, huh? Okay. Now we go on to intervals. Now, remember, intervals are really on the number line. So you have an interval from -6 to 2. The second interval is from 2 to 10. And I like to do this on a number line because I think it makes a lot more sense for students seeing a number line. So interval 1, what it does here, it goes all the way from -6 and it goes all the way to 2. And it's all this stuff right here in between. We don't include the -6, we don't include the 2. It's just the stuff in between the two numbers. Then you have interval 2. In comparison, we start off at +2 with the bracket, so we're including the +2, and we go all the way out to 10, but we don't include the 10. And again. Okay, it says find the union and then also find the intersection. So let's go union first. Union of interval 1, interval 2. Remember, union is if you have at least one graph, you get to write it down. Right. So do we have at least one graph at -10? Do we have at least one graph at -8? No. How about -7? Tricky question. How about at -6? Ooh, okay. Right, at -6 we still don't have a graph because it's not including a -6. It's anything above -6. But good job on the no. All right, so I can go from here. Both of them are included here. Right, we can get to +2. Now only the bottom one's included, but we still keep on writing it down all the way to 10. So there's my union. If you think about it, if you think of it like a sandwich, you scrunch it both down, and if you have at least one of them, you get to have it. Doesn't matter if you're eating the meat patty or the sandwich or the cheese, it's still good.
Why does that -2 not 2 have bracket? What is the second?
I don't know. First of all, can I correct a few little things here? Because I make mistakes rarely, but I sometimes do make mistakes. Right? If that's a +2, that's a +2. Shouldn't we do this right here, right? It should be right underneath each other. That's a lot better. Cool. Okay. So this 2, because it has a parenthesis, it means we're not including this 2 as the answer. The bracket means we are including the 2, and we include all the stuff after the 2 all the way up to 10. Good there? So if you think back to your high school math, I think it's like difference of open dot and closed dot.
Yeah, close.
Right? So parenthesis means open dot, and the bracket means closed dot. You're including that point. Okay. Still, is our answer correct though? Even with the moving of the 2 over? We're good. The 2 is not included in the top graph, but it's still included in the bottom graph, so we still include it as our answer. Okay, now the fun part. We have union intersection now. Intersection. Okay, so now the question is, if you put it together, where do both of them cross at the same time? Oh, sorry, you know what we should do for the first one here? We should actually write the interval. So the interval, because we're not expecting a graph, we're expecting an interval. So the interval should be -6 to 10. There's the final answer for union. Okay, intersection. What do they have in common? So if I were to put the sandwich together and they're electrical wires, the electrical wires will actually cross. Do you have both graphs at -6? Do you have both graphs at -2? Do you have both graphs at 0? Tricky question, do you have both graphs at 2? No, because the top one's not included. You got it. And after 2, you only have the bottom graph, so the answer is kaboom, right? 0 with the slash through it, there's nothing. That is the intersection. Where I sort of seen this before, it's kind of cool though, in automobile engineering. You have all these different formulas for thrust, for friction, for this, for that. And you got formulas for horsepower, right? I mean, there's certain things that you can't put together. So you can't have so much horsepower and all that horsepower going to the wheels. It's just not going to happen. You're going to lose something, right? So if you have 1,000 horsepower, the question is, can you have 1,000 horsepower on the wheels? Nah. You can have about 980, but that's about it. You're never going to have full thrust to the engines because of engine friction. Anyways, so impossible. Some things are actually impossible. Okay. 55 is gone, 51 is gone, 49 is gone. And so left with 67. Rewrite each expression without absolute value bars. That's kind of fun. And this is the tricky one. Makes you a little think from algebra. You're going to be subtracting two things here. Just real quick here, out of curiosity here, anybody know approximation for the square root of 3? We got 1.6, 1.79. Anybody grab a calculator here? Just press a calculator here. We'll get it today. We'll find it.
1.7320.
Awesome. Okay. So this is approximately 1.73. So then my question is, if you do this, 1.73 subtract 2, would that be a negative answer or positive answer? Negative. In fact, what will it be? Real quick here, those on the calculator here, what would this be? Negative 0.27. All right. Good there? But then you're going to have to add the absolute values in here, right? So you're going to have to do this then. So this answer would actually be positive 0.27. Cool. All right. How could I get a positive 2.7 out of here?
Because you're taking the absolute value.
Yeah, but if I try to do it without the absolute values, I'm going to try to write this expression without absolute values. How do I do this? Oh, okay, I'll give it to you. I'll give it to you. Let's see if I can find the little... Oh, look over here. We had some rules for absolute value, didn't we? On the notes, I just kind of gave it to you like, oh, here. And so on page 9, will sort of be kind of valuable for you in calculus. We have this little rule. Isn't that kind of weird? I think that's kind of weird rule. Is that true? A minus B, absolute value, is the same thing as B minus A, absolute value. Yeah, think some numbers in your head real quickly if you need to. So 7 minus 5 is a 2, right? Absolute value of 2 is 2. 5 minus 7, negative 2, and absolute value negative 2, 2. Hey, all right, cool. So if I'm going to rewrite this with absolute value, I can't have this little negative here. So the only thing I really got to do is, boom. Are we good? So let's see. The square root of 1.3 is a 1.73. If I subtract 2 from it, I will get a positive answer that actually does not need any absolute values with it. Are we good? Sweet. Okay, so let's... Are we good now? P1 is taken care of. Those are going to start on it tonight, right? If you haven't started on it yet.